Hello and welcome. Today we're going to be talking about angle pairs. As we look at, in particular, two lines that intersect. Anytime two lines intersect, they form angles, specifically four angles, 1, 2, 3, and 4 that I'm showing here in the picture. For angle pairs, this unit we're going to be looking at the different relationships between these angles and ways that they may be related. In order to do that, we need to understand some terminology. So looking at some vocabulary, we can start with adjacent. Adjacent angles, so any time you have angles that share a vertex and that share a side, we will say that those angles are adjacent. So if you look at angle 1, and if you look at angle 2, you can see that those two angles share a vertex and they share a side. You see how the blue and the red are on the same side? So those angles are adjacent to each other. To not be adjacent, you would need to have angles, for instance, 1 and 3. Even though they have the same vertex, they do not share a side. All right, so those would not be adjacent. Similarly, if you just had random angles floating off on the board with no connection, those would also not be adjacent. Now, we also know that two angles can form a straight line. So whenever you have a straight line, you could have another line intersecting that line, and that's going to form two angles. All right, we can call those angle 1 and angle 2. But the fact is that because this is a straight line, by definition, that will be 180 degrees. So the measure, we know, because this is a straight line, that the measure of angle 1 and angle 2 together has to be 180 degrees. All right? In particular, if they are in a line and they are adjacent, then we will say that they are a linear pair. Linear pair. So a linear pair is two angles that form a straight line. They have to be adjacent, and ultimately they have to add up to 180 degrees. All right? That's what makes them a linear pair. In general, we will see that angles that add up to 180 degrees we will refer to as supplementary. So again, these are all just vocabulary words that you need to sort of memorize so that you can know how to refer to these different angles. So supplementary angles add up to 180 degrees. Now they don't have to be a linear pair. You could have two angles. I could have this angle 1 and this angle 2. Those could also be supplementary, but not a linear pair. These two are supplementary and a linear pair. All right? So it can be both, or it can be one or the other. When we look at our intersecting lines, we see right away that we have some linear pairs. I'm going to actually redo the drawing here since I wrote on the picture a little bit. So if you have intersecting lines, we mark them 1, 2, 3, and 4. You can see that 1 and 2 form a straight line, 2 and 3 form a straight line, 3 and 4 form a straight line, and 4 and 1 form a straight line. Each of those angle pairs is going to add up to 180 degrees, and each of them is going to be a linear pair. So linear pairs in this picture are 1 and 2, 2 and 3, 3 and 4, and 4 and 1. Okay, all of those add up, each of those pairs adds up to 180 degrees. Based on that information, we can discover some new information about these angles that we really didn't know before. Specifically, if we know that angle 1 plus angle 2 is equal to 180 degrees, and if we know that angle 1 and angle 4 add up to 180 degrees, we can then because things that are equal to the same thing are equal to each other, we can say that angle 1 plus angle 2 is equal to angle 1 plus angle 4. So in other words, because these are both equal to 180, we can set that equal to that. Well, if you have angle 1 on both sides, we're going to subtract angle 1, and it just falls away to 0. And you see that angle 2 is equal to angle 4. So sort of algebraically now, we've just proven that angle 2 is equal to angle 4. And so we create a vocabulary term for that, and we call those vertical angles. Vertical angles. And vertical angles are always going to be opposite to each other around the intersection of two lines, and they will meet at the vertex, and they will be equal. All right, so vertical angles are equal. They are not adjacent. And in fact, they're opposing each other or on opposite sides around that intersection point. Do be careful when you do problems like this. Watch out for sneaky additional lines that might get stuck into the diagram. So they may have all sorts of lines running all over the place. And then let's say they name all these points, A, B, C, D, E, F, G, and H, and the intersection point is J. So be careful when you talk about vertical angles in a big picture like this with lots of angles. Be careful that you identify the actual ones that are the vertical angles formed by two intersecting lines, and that they are the same lines. All right, so for instance, G, J, F right here would be vertical to B, J, C right there. Those two are the vertical angles. Make sure that you don't think that somehow that they're equal to these two angles or to this angle. All right, be cautious and make sure that you're looking at the right set of lines. All right. So now we have these vocabulary terms: adjacent, straight line, linear pair, supplementary, and vertical angles. The last one that we're going to talk about is corresponding angles. Corresponding angles are a little bit different because you won't see them in this intersection of lines. Instead, where you'll see them is when there's some kind of perpendicular involved. Anytime you have a perpendicular involved, and then you have a line that cuts through that perpendicular, that's going to create two angles. So again, let me label this A, B, C, D, E, F, and G. And if you look at angle AGB and angle BGC, and let me color those for you. BGC and AGB, you can see that those two angles together form that right angle, and therefore they add up to 90 degrees. So we would call these two angles corresponding angles. I didn't say that right. Not corresponding angles. Complementary angles. Sorry. Complementary angles. All right. So complementary angles add up to 90 degrees. So angle AGB plus angle BGC equals 90 degrees, and those two angles are complementary. Another piece of vocabulary that you'll see in the textbook is that it talks about the complement of an angle and the supplement of an angle. Very briefly, if you know that angle 1 and angle 2 are supplementary angles, which means they add up to 180 degrees, then you can say that if angle 1, if you're referring to angle 1 as the angle, then angle 2 is the supplement of that angle. And angle 2, if you just do a little subtraction, right, angle 2 equals 180 degrees minus angle 1. So really, it's the same formula, you're just rearranging it. and you're thinking about it in terms of angle 2, which we're going to call the complement, the supplement of angle 1. So the supplement of angle 1 is 180 degrees minus angle 1. So in other words, it is that angle that when you add it to angle 1 equals 180 degrees. By the same token, for complement, if you have two angles that add up to 90 degrees, then the complement of a given angle is 90 minus that angle. That's about it for lines and angle pairs. Thank you for listening. This is John Buzzard signing out.